Okay, so we're going to be talking about parametric equations today. First, let's talk about rectangular equations. So let's say that we wanted to graph f of x, which means a function of x, which is our y, equals x minus 3 squared. Okay, so the first thing we do is that we start to pick values of x. Okay, so we can just pick any random values of x because x is our independent variable. Okay, so remember that word independent, so we can pick any values for that. Now what we pick for x determines what our y value is. That's why it's called the dependent, okay, because the values of y depend on what we choose for x. So let's look at what that is. So if we just choose x to be between 0 and 6, right, so 0, 1, 2, 3, 4, 5, 6, well then if we plug in 0 in for x here, then we get negative 3 squared, which is how we get 9. Right, so even though I chose these kind of randomly, 0, 1, 2, 3, etc., our y's depend on what we choose for x. Alright, now when we graph these equations, we graph our x and our y point. So at 0, our y is 9, so that's 3, 4, 5, 6, 7, 8, 9. Alright, when our x is 1, our y is 4. When our x is 2, our y is 1. At 3, we're 0. At 4, we're at 1 again. 5, we're at 4. And at 6, we're at 9. Okay, and then connecting these points, we see that we get this nice parabola. It looks like this. Okay, so we just randomly choose our x values, and that gives us our y values, which are dependent, and that's how we plot our points. Now, for parametric equations, we throw in a third variable. So we call this independent variable t, which is our input. This is also going to be known as our parameter. Okay, so we have a new independent variable, we call it t, and this determines our x and y values. So x is going to be a function of t, and y is going to be a function of t, so they both depend on what we pick for t. Alright, so let's look at an example. That'll be easiest. So for example, if we let x of t, which we can also call just x, equal x of t, which is t plus 3, if we let our y value, or our y of t function, equal t squared. Now let's say I want to pick values of t between negative 3 and 3, okay, which I've done here. Alright, so when t is negative 3, if I plug this in, then my x value is going to equal negative 3 plus 3, which is 0. Then my y value is going to be negative 3 squared, because that's t squared, and then I get 9. So that point is going to be 0, 9. Now if I plug in negative 2, then I have negative 2 plus 3. It gives me 1 for my x. If I plug in negative 2 here, then negative 2 squared gives me 4. So I have the point 1, 4. Alright, so go ahead and pause the video and fill these two out on your own. Okay, so over here I get 2, 3, 4, 5, 6. Here I get 1, 0, 1, 4, and 9. And that gives me these points over here. Now, when I plot these points, I would plot them like I would if I was in regular rectangular coordinates. Alright, so at 0, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have that point. However, now this point, I'm going to label this t equals negative 3. Alright, and then I have the point 1, 4. I'm going to label that t equals negative 2. Right, then I have the next point 2, 0, or 2, 1, excuse me. That's t equals -3. 3, 0 is my next point. That's when t equals 0. Oh, excuse me, that should be a -1. Right, then my next point is going to be 4, 1. That's when t equals 1. Next point is going to be 5, 4. That's when t equals 2. And my next point is going to be 6, 9, and that's when t equals 3. Okay, now notice that this has the same shape as the last graph, but now I have these t values here. I have -3, -2, -1, 0, 1, 2, 3. So now what I've done is I've given this graph a direction where my t's are increasing like this. So parametric equations are very useful because they give us a direction. Okay, they also give us a third parameter to express something. Right? So like let's say that this was t was my time, and x was my horizontal position, and y was my vertical position. Then at time 2, I can tell you that my horizontal position is 5 and my vertical position is 4. Okay, so let's move on. So as you can tell, we can change parametric into rectangular most of the time. So if we look at this graph of a parametric equation and this graph of our rectangular equation, notice that they make the same shape. Okay, so we're going to be talking about how we can go from parametric to rectangular. Alright, so let's start with this example. Let's say my parametric equation has x equal to 4t minus 3 and y equals the square root of t squared minus t. So first step is that we're going to solve x of t for t. Alright, you can also do this by solving y of t for t. Doesn't matter. Okay? It will matter. Sometimes you're going to get a nicer formula depending on which way you do it. Alright, so let's go ahead and solve this for t. So we have x equals 4t minus 3. So we want to get t by itself, so we're going to add 3 to both sides. We get x plus 3 equals 4t. We can divide both sides by 4. Okay, and that's going to give us x plus 3 over 4. That's our t value. Okay, now we're going to substitute that t in for our y. Okay, so had we decided to solve y of t for t, then this would be substituting our t in x. Okay, so since we know that t equals x plus 3 over 4, we can take this and plug it into this value. So we have that y equals the square root of t squared minus t, and I know that my t is x plus 3 over 4, so I can just take this value and substitute in here. So I have the square root. Instead of putting a t there, I'm going to put my x plus 3 over 4 squared minus, and instead of putting a t, I'm going to put this, x plus 3 over 4. Alright, now I could simplify this out. I'm just going to leave it as is. You don't have to simplify it, and this would be my answer. Okay, you know that you've done this correctly if you only have y's and x's. If you have a t in here, something's gone awry. Okay, so let's look at another example. Or no, let's look at this. So we've been using parametric equations this whole time. Remember, on the unit circle, we let our x value equal our cosine of t, where t was an angle between 0 and 2 pi, and we let our y equal sine of t. Same thing, where t was between 0 and 2 pi, and that was the unit circle. Okay, so go ahead, take a second, pull out your unit circle, and see that it is x equals cosine, y equals sine, that it is a parametric equation. Alright, but now how do we change the unit circle from parametric into rectangular? Okay, so how do we do this? Well, let's say that we take our x and we square it. and we take our y and we square it, right? Well, we know that that equals cosine squared, because remember, cosine was our x, plus y squared, and remember our y was our sine, and that equals 1. So then we get the rectangular equation of x squared plus y squared equals 1. So this would be our rectangular equation. But what if we had x equals 2 cosine and y equals 2 sine? So let's kind of go with the same logic we had up here. Let's have 2 cosine of t squared plus 2 sine of t squared. Right, so that's just my x squared plus my y squared. Okay, now if I square both of these, I get 4 cosine squared t plus 4 sine squared t. Right, I'm going to go ahead and I'm going to pull this 4 out since they both have it, and that's going to give me 4 times cosine squared t plus sine squared t. Now, remember the Pythagorean theorem that if cosine squared plus sine squared, we have that equals 1, so that's going to be 4 times 1, which is 4. So, we get that x squared plus y squared, x squared plus y squared equals 4. Alright, so let's get a general formula for this. The general rule of thumb is that if you have x of t equals r cosine of t plus h, and you have y of t equals r sine of t plus k, alright, so this is our parametric equation, both of these are parametric, then our rectangular equation is going to be x minus h squared plus y minus k squared equals r squared. So that r is going to be the radius of our circle, and h and k is going to be the center. So if we look at this equation here, okay, then our radius is going to be 3, because that is our r, so our radius is 3. Our center, hk, is going to be 4, comma, negative 2. Now if I rewrote this in parametric, or I'm sorry, in rectangular form, then I would have x minus, now notice that h is positive here, but I'm subtracting it, so it's going to be x minus 4 squared plus y minus that negative 2 squared equals 3 squared. Okay, so if I clean that up a little bit, it's going to be x minus 4 squared plus y plus 2, since a negative and a negative is positive. Then my 3 squared gives me 9. Now you can expand this and simplify it out. I'd rather you leave it in this form, because I can look at it and I can easily say, okay, that is a circle with radius 3, centered at 4 and negative 2. So just simplifying it, leaving it like this actually tells me more than if you expanded it. Alright, so we've looked at how to change from parametric to rectangular. Let's change from rectangular to parametric. Okay, so let's say I'm given this formula, y equals x squared minus 4x plus 2. Now down here I just rewrote that as x minus 2 squared. These are the same thing. Okay, I'm going to show you two different ways to do this. So if we pick something to equal t, well, the easy way is we could just let x equal t, or, see these parentheses here? We can go in here and we can let t equal x minus 2. Okay? Now I'm going to solve for t on this side, or I'm going to solve for x on this side, and I get x equals t plus 2. Okay? We could have also let something to do with y equal t. Works the same way, it just depends on which way looks easier to you. This way looks easier to me, so I'm going to go ahead and do that. Alright, now, since my x equals t, I'm going to substitute in t in my remaining function. Alright, since x equals t, then my y is going to equal, well, wherever I see an x, I'm going to put a t. So that's going to be t squared minus 4t plus 2. Or, if I let x equal t plus 2, then my y would equal, now see here, since I let this here equal t, then I'm going to have that y equals t squared. Okay? Now let's say instead of doing it this way, I substituted in x, which equals t plus 2. So let's do it that way. So let's say instead of writing down that x, I'm going to write t plus 2, which is what I'm letting my x equal, minus 2 squared. That equals t plus 2 minus 2 squared, which just gives me, again, t squared. Now you should always end up with two equations. You should end up with one x equation and one y equation. Okay? So this is my two equations on this side. Over here, I have my x and I have my y. Alright, and these two go together, and these two go together. I can't be mixing them up. I can't have x equals t and y equals t squared together, and I can't have these two together. So make sure that you group them appropriately like this. Okay, moving on to the next video.